Most probable number calculation using Poisson distribution can be applied for any number of samples where P of D probability of dilution is given by 1 minus e power minus n1 lambda whole power p into e power minus n1 lambda whole to the power of q1 p1 into 1 minus e power minus n2 lambda to the power of p2 into e power minus n2 lambda whole to the power of q2 and so on, where n1, n2, n3 and so on are sample sizes. Lambda is coliform density in number per ml. P1, P2, P3 and so on are number of positive tubes, and Q1, Q2, Q3 and so on are number of negative tubes. Our MPN per 100 ml will be the lambda corresponding to maximum PD, lambda corresponding to maximum value of probability of dilution. Example, now in this example N1 is 1, P1 is 4, Q1 is 1, N2 is 0.1, P2 is 3, Q2 is 2, N3 is 0.01, P3 is 2, Q3 is 3, N4 is 0.001, P4 is 0 and Q4 is 5. So now probability of dilution is given as 1 minus e power minus n1 is 1 into lambda whole to the power of p1, that is 4, into e power minus 1 into lambda to the power of 1 into 1 minus e power minus 0.1 into lambda to the power of 3 into e power minus 0.1 into lambda to the power of 2 into 1 minus e power minus 0.01 into lambda to the power of 2 into e power minus 0.01 into lambda to the power of 3 into 1 minus e power minus 0.001 lambda to the power of 0 into e power minus 0.001 lambda to the power of 5. Now corresponding to different lambda values, we can find probability of D values. Say lambda equal to 3.8, probability will be 3.6754 into 10 power minus 7. When lambda is 3.84, probability will be 3.6773 into 10 power minus 7. Lambda corresponding to 3.85, our probability will be 3.6774 into 10 power minus 7. Probability is 3.86, it will be 3.6773 into 10 power minus 7. So our maximum is obtained at this value, that is lambda is 3.85. So our MPN per 100 ml will be 100 into 3.85, that is equal to 385 numbers per 100 ml. Whereas MPN using Thomas equation will be MPN per 100 ml will be equal to number of positive tubes positive tubes into 100 by under root of ml of sample in negative tubes into ml of sample in all tubes. For example, taking the same example in which number of positive tubes are 4, 3, 2 and 0. So sum will be 4 plus 3 plus 2 plus 0, that is 9. Now ml of sample in negative tubes will be corresponding to 1 ml. There is one negative tube, so 1 into 1 plus corresponding to 0.1 ml there are two tubes, so it is 0.1 into 2 plus corresponding to 0.01 there are 3 tubes and 0.001 there are 5 tubes. So writing that 0.01 3 tubes, 0.001 there are 5 tubes, so the total will be 1.235, whereas ml of sample in all tubes will be, there are 5 tubes corresponding to 1 ml dilution plus there are 5 tubes corresponding to 0.1 ml dilution plus 5 tubes corresponding to 0.01 ml dilution and 5 tubes corresponding to 0.001 dilution. So this will be 5.555. So using Thomas equation, MPN per 100 ml will be equal to number of positive tubes, that is 9 into 100 by under root of ml of sample in negative tubes, that is 1.235 into ml of sample in all tubes, that is 5.555 under root, which will be equal to 344 per 100 ml. Whereas MPN can be calculated from table values, that is from this table, which is given for standard dilution 10 ml, 1 ml and 0.1 ml corresponding to the number of positive tubes. Say some 4, 1, 0 are our positive tubes, then corresponding to that MPN will be 17 per 100 ml. To obtain other than standard dilution, this is standard dilution. For other dilutions, say 1 ml, 0.1 ml and 0.01 ml, which is 10 times, on multiplying with 10 the standard dilution is obtained. So MPN from table, that is 17, should be multiplied with 10, that is 170 will be our MPN corresponding to the positive dilutions 410. Whereas for dilutions 100 ml, 10 ml and 1 ml, on dividing with 10 our standard dilution will be obtained. So MPN from table should be divided by 10, that is 1.7 per 100 ml will be the MPN corresponding to positive tubes of 410. When more than 3 dilutions, some 4 or 5 dilutions are used. In first case, positive tubes are 5, 5, 2 and 0. We have to take 5 to 0, that is highest dilution having maximum positive tube should be considered, and its next two dilutions are taken. Next two higher dilutions are considered. That is, in the first A sample, 1 ml, 0.1 ml, 0.01 ml, 0.001 ml and 0.001 ml. Highest dilution out of 1 and 0.1 is 0.1 is the highest dilution, in which there are positive tubes 5 by 5. So the next two dilutions are 2 and 0. So we need to consider 5 to 0 for the MPL from table, corresponding to dilutions 0.1 ml, 0.01 ml and 0.001 ml. So MPN from table, that is for from the table, corresponding to 5, 5, 2 and 0, our value is 5, 2 and 0, our value is 49. So it will be 49 for standard dilution 10 ml, 1 ml and 0.1 ml. To obtain that, we need to multiply it with 100. So multiplying it with 100, it will be 49 into 100, that is 4900 is our MPN for A. Whereas for B, highest dilution is for positive results is 5. So next two dilution should be considered. It is 5, 4, 2. From table value corresponding to 542, its value is 220. It should be multiplied with, to obtain the standard dilution, that is, this is our actual dilution. To obtain standard dilution 10 ml, 1 ml and 0.1 ml, 0.1 ml, our actual one should be multiplied with 100. So multiplying it with 100, it will be 22,000. So this is 000. Whereas for C sample, we need to consider 0, 1 and 0 as a positive dilutions, just to include the positive dilution 1. So corresponding to this, MPN value from table is, for this dilution is 0.1, 0.01 and 0.001. This is point, so this is 1 only. Corresponding to this, the dilution is, corresponding to this, the MPN value is 0.18. It should be multiplied with 100, so it becomes 18. Whereas in the D case, we need to take the sum of last to 1 and 1, and we need to consider 5, 3, 2 as the positive samples, and corresponding to which the MPN value is 140. It should be multiplied with 100 to obtain our actual value, that is 14000. So this is 0. And at last, E also, sum of this and this should be added and taken, that is 542. Corresponding to 542, the value is 220. It should multiply with 100, so it becomes 22000. This 0. For our example, that is number of positive samples 4, 3, 2 and 0. Using table, the positive samples are 4, 3, 2, 0. Excluding the 0 value, 4, considering the 4, 3, 2, our MPN from the table will be, corresponding to 432, our MPN is 39 for standard dilution 10 ml, 1 ml and 0.1 ml. To obtain at our derived dilution, we need to multiply it with 10, since our dilutions are 1.1 and 0.01. So for 1 ml, 0.1 ml and 0.01 ml, it should be multiplied with 10, that is 390 is our MPN per 100 ml using table.